how to calculate the dimensional formula of pressure. Okay, today I will show you. Okay, so you know what is pressure, so I will show you how to solve this. Okay, you know we need to calculate the dimensional formula, dimensional formula of pressure. Even I put the shorts and video of this, I am going to explain it today on live, so that any question you can put up into the chat box and I will reply to you. Okay, so what is a pressure? We need to understand the definition of pressure. Pressure is force applied force applied per unit area, this is the definition of pressure, right? You know, this is the force applied per unit area, right? So we can write, if pressure is P, we can write it as F by A. If force is denoted by F and area is denoted by A, right, then we can write pressure as force per unit area, right? And force, how we can just further break it? Force, the force can be further broken as mass into acceleration. How? We know by Newton's law, F equal to ma, rate of conservation of the delta m into delta v, right? So this will give you m into a. So F equal to ma, we can write it, and in place of area, it will be just, area can be calculated. You remember the area. What are the units? Always centimeter square, meter square, decimeter square, whatever. So it coming into a square. So 2 times length will be coming. Square, that means 1 unit for this and 1 for this, right? So in this way, for mass, we can write, we will just write it to the next step. First elaborate this acceleration also. And what's the unit of acceleration? For calculating any dimensional formula, just consider the unit of that particular objects or item, physical items which given over here. For mass, it will be kg, right? It will be kg. And for acceleration, the unit will be meter per second square, right? So meter is also a length, and into the denominator 2 times length, into length, right? So here we can further write it as mass or kg, just we will put into the next step, into meter per second square. That means whatever be the length, its unit is meter. So length into second square, we can write it as, second is the unit of time. So when it will come upward, second power minus 2 by length into length. So here one of the length will cancel out this one of the length. Now we are left with mass. For mass kg, it is m. The dimensional formula, as per the dimensional formula in physics, for mass we represent it by m, and for second square it will be t power minus 2, because second is the unit of time, right? So we are writing it as t power minus 2, and one length is left over here into the denominator. When it will come upward, it will be coming as L, because length is denoted by L, and when it will come into the numerator, it will be minus 1, right? So the dimensional formula of pressure is calculated as ml minus 1 t minus 2, right? So this is the dimensional formula of pressure which we have derived here. So students, in calculating any of the dimensions or any of the dimensional formula of any physical quantity, for force or for whatever, it can be acceleration, it can be pressure or whatever, so you will just take into your mind that what, just write the definition first and see what are the components which are coming into it. So here we are knowing the definition of pressure, that is the force applied per unit area, right? So we have just put up the definition over here, and just after that we have written force can be written by Newton's law as mass into acceleration, and this mass into acceleration, what is the unit of mass? Mass is kg, acceleration is meter per second square, and meter is a unit of length, second square that means time. So it will be coming as, and one, an area can be considered, or you can remember in mensuration or in your studies that area, the what is the unit of area? It's meter square, centimeter square, decimeter square. So 2 times length will be coming. So this is into your denominator. So one of the length of the numerator will be cancelled out with one of the length of the denominator. Why? This meter per second square of acceleration. So this meter will cancel out this length, because this is also a length. Now we are left with one mass. For mass, the dimensional formula is capital M, that is in kg, for its m, and for second minus 2, second power minus 2, that means second is the unit of time, so it's t power minus 2 here. And for in the middle, the length of the denominator will come upward, then we can say for length it's capital L. So capital L, when this denominator, the length of denominator will come upward, it will be showing at L power minus 1. So the dimensional formula of the pressure is M L minus 1 T minus 2. Right, students? So in this way we have solved this question, right? Similarly, for suppose you are calculating it for force, right? Should I show you? So for force it's very simple, it's mass into acceleration. For force it's very simple, it's mass into acceleration, and mass is a unit of mass is kg, and acceleration is meter per second square. So for kg it's m, for meter it's L, and second square is time unit, coming into numerator power minus 2. So mlt minus 2 is the unit of dimensional formula of force, right? So students, in this way we can calculate any of the dimensional formulas. Though we have used this over here, because we have already force into the numerator, we have just area into the denominator, force per unit area is pressure, and force can be written as mass into acceleration, and area can be written as length into length. Now unit of mass, just in writing the dimensional formula, just remember the units. So considering the units, we have derived the dimensional formula of pressure as ml minus 1 t minus 2. So thank you for watching, students. Keep on learning. Happy learning. Bye bye.